Computer Organization and Design, RISC-V edition, the hardware-software interface. This is second edition. The computer contents. The computer abstract, and an introduction. The 7 great ideas in computer architecture, and 7 below your program. Under the covers, technologies for building, processors and memory, performance, the power wall, and the sea change, the switch from uniprocessor to multiprocessors. Real stuff, benchmarking the Intel iCore i7, going faster, matching multiply in Python, fallacies and pitfalls, concluding remarks, historical perspective and further reading, self-study exercises. Chapter 2 is the introduction, instructions, language of the computer. Introduction, operation of the computer hardware, and operands of the computer hardware, signed and unsigned numbers, representing the instructions in the computer, and logical operations, and introduction for making decisions, supporting procedures in computer hardware, and communicating with people. RISC-V addressing of the wide, immediate, and addresses, parallelism and instructions, synchronization, translating and starting a program, and a C-sort example to put it all together. And lists, arrays versus pointers, advanced materials, compiling C and interpreting Java. Real stuff, MIPS instruction, ARM version 732-bit instruction, ARM version 64-bit instructions, and x86 instructions, the rest of the RISC-V instruction set, going faster, matrix multiply in C, fallacies and pitfalls, concluding remarks, historical perspective and further reading, self-study exercises. Chapter 3, Arithmetic for computers. 1. Introduction, addition and subtraction, multiplication, division, floating point, parallelism and computer arithmetic, subword parallelism, real stuff, and streaming, SAMD extensions and advanced vector extensions in x86. Going faster, subword parallelism and matrix multiply, fallacies and pitfalls, and concluding remarks, historical perspective and further reading, and self-study exercises. The processor, introduction, logic design conventions, building a data path, a simple implementation scheme, multi-cycle implementation, an overview of pipelining, data path and conclusion, data hazard, forwarding versus storing, control hazard, exception, parallelism via instructions. Put it all together, the Intel i7 core 6700 and ARM Cortex A53. Right, 53. And then going faster, instruction level parallelism, ILP, and matrix multiply. Advanced topic, an introduction to the digital design using a hardware design language to describe and model a pipeline, and more pipeline illustrations, fallacies and pitfalls, concluding remarks, historical perspective and further reading, self-study, a large and fast, exploiting memory hierarchy, and introduction is memory technologies, the basics of the caches, measuring and improving the cache performance, dependable memory hierarchy, virtual machines, and virtual memory, a common framework for memory hierarchy, and using a finite state machines to control a simple cache. Parallelism and memory hierarchy, cache coherency, and a parallelism and memory hierarchy, redundant arrays of the expansive disks, RAID, and advanced material implementing cache controllers, real stuff, the ARM, Cortex A8, and Intel Cortex Core i7 memory hierarchies. Real stuff, the last of the RISC-V system and special instructions, as going faster, cache blocking, and metric multiply. Balances and p-force, concluding remarks, historical perspective and further reading, self-study and exercise. Chapter 6. Parallel processors from client to cloud. Introduction. And the difficulty of creating parallel processing programs, SISD, MIMD, SIMD, SPMD, and vector. Hardware multithreading, multi-core and other shared memory multi-cores, multiprocessors, and the introduction to graphic processing units, domain-specific architectures, and clusters to warehouse scaling computers and other messaging passing multiprocessors. Introduction to multiprocessor network topologies, communicating to outside world, cluster networking, multiprocessor benchmarks and performance models, real stuff, benchmarking and Google TPU version 3 supercomputer and NVIDIA Vertex GPU cluster, going faster and multiple processors and metric multiply, fallacy and pitfall, concluding remarks, historical perspective and further reading, self-study, exercises. The basics of the logic design. Appendix A. The basics of the logic design. Introduction. Gates, truth table, and logic equations, combination logic, and using a hardware description language, construction of a basic arithmetic logic unit, and a faster addition, carry look ahead, clocks, memory elements, flip-flops, and latches and registers, and SRAMs and DRAMs, and a finite state machine and timing methodologies, field programmable devices, and concluding remarks, exercise. Online content, graphics and computing GPUs, introduction, GPU system architectures and programming GPUs, multi-threaded multiprocessor architecture and parallel memory system, floating point arithmetic, and the real stuff. The NVIDIA GeForce 8800 real stuff, mapping applications to GPUs, and palaces and people, and concluding remarks, historical perspective and further reading, mapping control to hardware, introduction, implementing a combinational control unit, implementing finite state machine control, implementing next state function with a sequencer, and translating a microprogram to hardware, and concluding remarks and exercise, survey of the instruction set architectures, introduction, a survey of RISC architectures for desktop, server, and embedded computers, the Intel 80, x86, and the VAX architecture, and IBM 360 and 370 architecture for mainframe computers, historical perspective and references. Okay, I will read this book. Thank you for your time and see you next time.